Right, so y equals x cubed minus 3x squared minus 9x plus 6. So it says find the turning point and state if it's a maximum or a minimum. Right, okay. So to find the turning point, you get dy dx and you let it equal to naught. Okay? So dy dx is 3x squared minus 6x minus 9 equals 0. Agreed? Right, okay. Now, if you're using the minus b formula, off you go, use the minus b formula from there. Right? If you're finding factors, which is what I'm going to do, I'm going to divide everything by 3 because it makes finding the factors that bit easier. So 3 divided by 3 is 1, so I just get x squared. 6 divided by 3 is 2x. 9 divided by 3 is 3, equals 0. So then I do my two sets of brackets. I have x and x. I have 3 and 1. Different signs, so if I have minus 3 plus 1, check your answer. On the inside, minus 3x. On the outside, I have plus 1x. And that's minus 2x. Right? To finish that off, you let each bracket, I'll go up here, you let each bracket equal naught, so you let x minus 3 equal naught, and you let x plus 1 equal naught. So you get x is equal to 3, and x is equal to minus 1. So that's what you should have got. That's where we, if you use the minus b formula, we're back together again now. Right, that's what you should have from the minus b formula. So x is 3 and x is minus 1. Okay? Right. Am I okay? Did I write it down? Do you agree with me? Yeah. Okay. So then I go right back up to the the curve up at the top. 3x squared minus 9x plus 6. Right, that's how I get my matching y. Right back to the very start, what they told me in the question. Okay, everywhere I see an x, I'm putting in a 3. So I get y is equal to 3 to be cubed minus 3 times 3 to be squared minus 9 times 3 plus 6. Okay, so that would be minus 21. Did you get that? Right. So that's the point 3 minus 21. Okay. Then I have to sub in x is minus 1 to get my other point. So x is minus 1. So I have minus 1 to be cubed minus 3 times minus 1 to be squared minus 9 times minus 1 plus 6. So into the calculator with that, and you'll get minus 1 minus 3 is minus 4 plus 9 is 11. Did you get that? Yeah. So it's minus 111. Okay. So then to figure out, today I'm going to show you another way to figure out which one is the max, which one is the min. Right. Okay. But for now, we're going to just graph. So imagine if you were graphing 3 minus 21, you go across 3 and way off down to minus 21. Okay. Isn't that right? And minus 111, you'd go across to minus 1 and up to 11, wouldn't you? Right? So this would be the maximum, because when you were drawing it, that would be up high. And this would be the minimum, because if you were to draw it, it'd be way down low. Is that okay? Right? Are we okay with that? Right. Any other? So we had 2, 3, 5 and 7. That was number 5. Does anyone need me to do any of the other ones? No? Right. Are you sure? Right. Okay. So today we're sticking with the same thing, but rather than sometimes they ask you to show mathematically what is the max and what is the min, as in you can't draw it. Okay, so there's another way of getting it, okay? Right, okay. So before we start, I need to tell you what the second derivative is. right? So the second derivative is, if you have a function and you differentiate it, like we had there, we've been doing all along, and we got dy dx, right? Then you can differentiate again. So whatever your answer is, if you differentiate that again, that's called the second derivative, girls, which is called d2y dx2. Okay? Now, it sounds quite complicated, but when you see an example, it's just differentiate and differentiate again. Okay? Right? So it's differentiate and differentiate again. Right? And what I didn't tell you is, sometimes instead of saying, they tell you, I should have told you this when we were doing the first derivative. Sometimes they said, here's y, find dy dx. But sometimes they say, instead of y, remember when we did functions, we said instead of y, sometimes y is written as f of x. Right? So if they said, if they use f of x instead of y, they'll say find f dash of x, which is the same thing, differentiate. Okay, so it's just a new way of writing it. It's not a new way of doing it. Okay? And if they want to differentiate again, they'll ask you to do find f double dash of x. Right, so that means differentiate it again. You all look pretty confused at the moment. Okay, but wait till you see an example. It's not, it's actually fine.
Does that say third, like F? Does that say F11?
It said f double dash, right? It's like an apostrophe. It's like two apostrophes. Okay, is that right? Okay, so f double dash of x. Right, I was just about to do a roll because I was saying there's a lot of blank text there, but you're all here now. Okay, ready?
No.
Right.
Is this the very first thing we did, or did we miss a bit?
You missed a bit.
Yeah.
I'm recording it, so yeah. If you just want to jump in now, and you can catch up on the recording, okay?
Does that say F11?
It says f. It's actually f double dash. It's called f double dash of x. So it's like two apostrophes. Okay. So it's called f double dash. You don't say f11, right? But no one will ever ask you to say it. They'll just ask you to do it. So if you just know what it means you to do, you can call it whatever you want. Okay? Ready? Right. Okay. So I'm going to go to an example. Right? Example 1. So here's y. And it says find d2y dx2. So all they want you to do is differentiate and then differentiate again. Okay? So look, I'll just write down y here. Y is equal to x squared plus 2x minus 4. So if I differentiate, I'll call it dy dx. So differentiate there, what will I get? 2x plus 2. Thank you. Right? And what you do is you differentiate again, and you call it d2y dx2. Again, girls, you don't need to remember that because it'll be written in the sum for you. Okay? So you differentiate again, and differentiate the answer. Differentiate that, what will I get? 2. Just 2 on its own. Isn't it? Differentiate the next term, you get the number in front. Differentiate 2, you get 0. That's it. Right? So you differentiate and then differentiate again. Yes. This?
Yeah. Miss, could you ever get D3Y?
No. Yeah, they'll just ask you to differentiate once or differentiate twice, and that's it. Okay?
That's D-E-R-I-V-A-T-I-V-E.
Say that again. Derivative. D-E-R-I-V-A-T-I-V-E. Sorry. I have my hand fixed next Friday, so my writing should improve. Yeah. It's getting, next Friday I'll be fixed, so. Now I could just have bad writing, it could have nothing got to do with my hand, but yeah. Are we okay? Are we good? Can I go? Right, example 2. Right, so this time, girls, they called it f of x. Right, okay? So it's the same thing. Instead of y, we say f of x. Right? So it's 2x cubed plus 3x squared minus 4x plus 7. So they say find f double dash of x. Right, so that just means differentiate and then differentiate again. So if you differentiate it once, we call it f dash of x. So if you want to call it dy dx, knock yourself out, you can. Right, okay? What you call it is really irrelevant as long as you're able to do it. Differentiate, 3 by 2 is 6x to the power of 2. Okay, differentiate here, you'll get 6x, isn't that right? And differentiate here, you'll get minus 4, and differentiate 7, you get 0. Are we okay? Differentiation, you're all flying at that, I presume. Are you? Right, okay. And then f double dash of x just means take your answer and differentiate it again. Right? So take your answer, differentiate it again. So differentiate here, you can bring the power down in front. 2 by 6 is 12, x to the power of 1, which is just x. Right? And here, differentiate 6x, you get 6. Differentiate minus 4, you get 0. And that's your answer. Is that alright? Okay? So there's not a lot to it really, is there? It's just differentiate again. So get your answer, then differentiate it again. Okay? Right? Okay. Now we're going to go on to why would you do it? Right? Okay? So like before when we started the chapter, I said don't ask me why, just ask me, I'm going to show you how. Same thing, I just showed you how to get d2y dx2. Now I'm going to tell you why. And it's got to do with turning points. We're still on the same section. Okay? Right, so are we okay? Moving on? Right, okay. Using the second derivative to determine the nature of the turning points. Okay? So basically, you can use d2y dx2 to find out whether the turning point that you've just calculated, so you still do the turning point like before, get dy dx, let it equal to 0, solve it. You get your turning point, right? And up to now, right, we've been saying, well, the turning points, we're graphing it and we're saying if it's up high, it's a max, if it's down low, it's a min. That's the easiest way to do it, but you also have to know this way to do it, okay? So what you do is you get dy dx, you let it equal to 0 and you solve, right? Then you get d2y dx2 and you fill in the value for x. And if it's less than 0, as in, if the answer you get is negative number, if it's less than 0, i.e. if it's negative, right? So if it's a minus number, it's a max turning point. And when you fill in, if the number you get is positive, it's a min turning point. Now it's the opposite to what you think, right? Because max, you might think, oh, max is positive, but no, it's max is negative, min is positive, okay? Again, that's only words until we do an example. Are we okay? Can you read my writing?
What's the thing before it says is negative?
What's the thing before it says what?
Never mind, I have a thing.
You're okay, sorry. Also, what's probably not helping is I wrote these slides yesterday because I thought we'd get to this yesterday, but we didn't.
Does that mean that the maximum turning point, dy dx, is always going to be greater than 0?
d2y dx2
Yeah.
is less than 0 for maximum. Did you say maximum or minimum? Maximum it's always going to turn out to be, it's less than 0, it's always going to be a negative number,
Okay.
right? And for a minimum, it's always going to be a positive number. So it's the opposite to what you think.
So if we have a negative number for the minimum, it's not.
If you have a negative number for the mean, yeah, but it'll be fine. Okay, that won't happen. You won't get it wrong. Right, I'm confident. Right, okay. So I thought I had more slides. Okay. Right, an example. So let's go back to number 5 from last night, because I still have it. Okay? So, example 1. Right. So it's the exact same step as we were doing last night. You get dy dx, you let dy dx equal to 0, you solve for x, then you get your matching y values, right, okay, and then we're going to use d2y dx2 to determine whether it's a max or a minimum. Why the hell would you do this? You wouldn't do it unless they specifically ask you to do it, okay? So sometimes they'll say, find the turning point, say whether it's a max or a min, and then you just graph, right, okay, because it's faster, right? Yes. Yeah. Zoom in. Right. Is that okay? Right, okay. So example 1, this is question 5 from last night. Okay? So we've ended up with our turning points. Okay? So, but then it says use d2y dx2 to determine whether it's max or min. Right? So that's the only time you'd use it, when they tell you to use it, because the other way is way shorter. Okay? Is that right? Okay. So what you do is, let's use d2y dx2. So let's get d2y dx2. So look, dy dx, I got it up there, x squared minus 2x minus 3. Isn't that right? Got it up there. Okay? So now I'm going to get d2y dx2. So can I move it up a small bit? Right? So I'm going to get d2y dx2. So that means I'm just going to differentiate the answer. So what's the answer here to d2y dx2? 2x minus 2. Now, I have 2 points, right? So I solved like I was doing last night, and I ended up with 3 minus 21 and minus 111. They're the 2 points I ended up with. Is that okay? So x is 3, y is 21. You don't need y. Remember, you just fill in for x. Remember what we did in the very first section of the chapter? Okay? So everywhere you see an x, put in a 3 here. Okay? So put in a 3. 2 times 3 minus 2 equals 4. Right? Is that a positive or a negative number? Positive number. And what's the story if you end up with a positive number? What do the rules say? If it's a minimum, so that's a minimum. So that's a minimum TP, turning point. Okay? So minimum TP. Okay? Right? Here, let's figure out what this one is. It's obvious it's going to be the maximum. If one's the min, the other's the max. But let's prove it. Right? So into d2y dx2, everywhere you see an x, put in a minus 1. So it's 2 times minus 1 minus 2. So that would be minus 4. Is that a positive or a negative number? Negative number. And the rule said if you end up with a negative number, that's a maximum. So that must be the maximum turning point. Right, and as I say, girls, you'd only use this if they specifically said to use it, right? Because it's easier to imagine which one's up high and which one's down low. Okay, is that right? Okay, so I'm going to do an example from start to finish. Right, okay. So this will be example 2. Find the coordinates of the turning point of the curve use d2y dx to determine the nature of the turning point. So the nature of the turning points, girls, is it a max or a min? That's just what nature of a turning point means. Is it a max or a min? Okay? Okay, so here's my curve, right? So we know at the turning points, girls, we know dy dx equals 0. So at turning points, dy dx equals 0. How do we know that? Because we learnt it, right? Okay? Because Miss Enright told you to learn it, right? Okay, so y is equal to 12x minus x squared. Oh, no, it's fine. 12x minus x cubed. Is that okay? Then we get dy dx. So what would dy dx be? 12 minus 3x squared. Isn't that right? So that's dy dx, and I'm going to let that equal to 0, and I'm going to solve it. Okay? So right, I'm going to that's going to be, I'm going to rewrite it, minus 3x squared plus 12x equals 0. Right, I've just written it in a different order. I put the 3x squared first and the 12x second. I haven't changed anything, right? I've just written in a different order. If you're using the minus b formula, girls, what's a equal to? Minus 3. What's b equal to? 12. What's c equal to? 0. So if you're using the minus b formula, there you go, off you go. Right, okay? Right, you know I like to factorize, so I'm going to factorize. So the first thing I'm going to do is I'm going to divide everything by minus 3, because it makes life easier, right, to find the factors. So divide everything by minus 3. So here I'll get x squared, a plus divided by a minus is minus 4x equals 0. Then to solve this, I take out what's common. So what's common? X. So it's x into x minus 4 equals 0. Okay. Then you let x equal 0. So it's let each bracket equal 0. So the first bracket is just x on its own. So that's one answer. And the second bracket is x minus 4 equals 0. So that means x equals 4. So there's my two x values. So if you're using the minus b formula, we're back together again. Right? Because you found x is 0 and x is 4. Are we okay with that? Right? So you have to go right back up to the very top to get your matching y's. So y equals 12x. Yes. Oh, it's minus, sorry. Ignore everything I just said there. Right, okay. So, you know, when you differentiate, you get minus 3x squared plus 12. Yeah? Right, okay, not 12x. Okay, it is, but when you differentiate, you get 12. So it's, when you differentiate, it's 12 minus 3x squared. And then, look, I differentiated it right, and then I decided to put an x on it. Right, it was a test. Right, okay, so I'm going to write it in a different order. Minus 3x squared plus 12. Right, okay. So, sorry, there's no x there. Right, I'm going to divide by minus 3. Minus 3. Sorry, what I should have said there before I do that. If you're using the minus b formula, a is what? What's a? Minus 3. What's b? 0. It's the number in front of x. Right, there is no x term. Right, and what's c? 12. Okay, is that alright? Okay, so a is the number in front of x squared, b is the number in front of x, there is no x term, so it's a 0, and c is a number on its own. Okay, so I'm going to divide everything by minus 3, so I can, so I'll end up with x squared, a plus divided by a minus is a minus 4 equals 0. Right, to factorise this, girls, it's the difference of two squares, so it's x to be squared, take away 2 to be squared, and that's two sets of brackets, x and x, 2 and 2, a plus and a minus. Then to solve, I let each bracket equal 0, so I get x plus 2 equals 0, x equals minus 2 when it comes over, x minus 2 equals 0, x equal to plus 2 when it comes over. So now if we've done the minus b formula, now we're back together. Okay? Yes? Because, you know, b is the number in front of x. So normally there's an x squared term, there's an x term, and there's a number. Okay? So a is the number in front of x squared, b is the number in front of x, so this is a, this is b, and c is whatever the number is. Agreed? Right, so a is minus 3, b is the number in front of x, there is no x term there, right? So that means it's 0x, as in it's not there, so that's why b is 0. Is that alright? Okay, right, so now we're back together, so back up to the top, it's y is equal to 12x minus x cubed. So everywhere you see an x, put in a minus 2, so that means y is equal to 12 times minus 2 to be cubed. So that means y is equal to minus 24 minus 8 minus 32, I think. Yeah. So that's the point, minus 2 minus 32. Agreed? Over here, everywhere I see an x, put in a 2. So it's 12. Oh, sorry? Yeah, sorry. 12 times 2 minus 2 to be cubed, which is 16. So that's 216. Yeah?
There's no, is it not minus 2 in the bracket, so it would be minus 2 squared,
That's minus 24, and that's minus 2 to be, oh, it's minus 2 to be cubed, oh yeah, it would be, yeah, sorry, oh, you know it's Friday, so that would be, you'd be doing it on your calculator anyway, so you end up at minus 16, I think?
Yeah.
Right, sorry, minus 16. Is it possible to make another mistake in this sum? Probably, yeah. Right, okay. Sorry. So look, I have 2 points now. Right, okay. So, look, we know, you know, by looking at it, which one is the max and which one is the min. What's this one? That's the min because it's down low, isn't it? And that would be the max because it's up high. Because it's minus 2 minus 16. And the other one is 2, 16, right? So this is the min, this is the max, right? So we know the answer, okay? But it says to use d2y dx2. So above we had dy dx So we got dy dx above, and dy dx above was 12 minus 3x squared. Isn't that right? Okay, differentiate again. So what's d2y dx2? What's d2y dx2? It's minus 6x, isn't it? Because differentiate 12, you get 0. Differentiate minus 3x squared, you get minus 6x. Okay? So I ended up with 2 points there. It was minus 2, minus 16, and 2, 16. Isn't that right? They're both my points that I found out. What I was doing last night, basically. Right? This is x, this is y, this is x, this is y. Y doesn't matter. All you have to do is fill in the x into d2y dx2. So here we have minus 6 by minus 2. So minus 6 by minus 2 is plus 12. Is that a positive or a negative number? Positive. And if you end up with a positive number, what does that tell you about the turning point? It's a minimum. It's the opposite to what you think it was, okay? So it's the minimum turning point. Right? And here, obviously the other one has to be the maximum, but let's prove it. Everywhere you see an x, put in a 2. So minus 6 times 2 is minus 12, which is a negative number. So if you end up with a negative number, that is a maximum turning point. Okay, is that alright? And they're long, right? Okay. So let's do page 255, numbers 14 and 15. Okay, so I'm only giving you 2 because they're long. So page 255, 14 and 15.